Namaskar. Today we will be discussing part 2 of the session 3 that remains inconclusive, and I will be discussing today the component of exposure in disaster risk management. Continuing from our previous talk on vulnerability, let us go deep into the exposure which is affecting the disaster risk management. Unlike vulnerability, which reflects susceptibility, exposure indicates the extent to which people contact with potential hazards. Understanding exposure helps identify who and what are directly at risk, shaping how we prioritize disaster preparedness and mitigational strategies. Let us try to define exposure. Exposure is defined as the location and proximity of assets and populations to hazards. Unlike vulnerability, which is inherent, exposure focuses on where people and infrastructure are situated in relation to hazards. It plays a crucial role in disaster response and risk analysis by showing the physical scope of potential impacts. For example, Miami in USA is highly exposed to hurricane due to its coastal location, while Istanbul faces exposure to earthquakes because of its proximity to tectonic fault lines. Nepal and Indian Tarai region faces exposure to earthquakes being in zone 5. Recognizing and assessing exposure helps prioritize where mitigational efforts are needed most. What is the importance of exposure in risk management? Exposure assessment is vital in disaster risk management as it helps to quantify potential losses and scale of impacts. Area with high exposure but inadequate protection can face devastating outcomes. High exposure such as Tokyo with its dense urban population increases the potential for severe impacts during a disaster. This acknowledges helps allocate resources efficiently and create protective measures for high risk areas. Now let us talk on population density and its role in exposure. Population density is a very significant factor in determining exposure to hazards. High density areas mean more people and assets concentrated in smaller spaces, increasing potential casualties and damage. For example, in cities like Mumbai, where millions live in close quarters, disasters can lead to higher casualties and overwhelmed emergency services. Effective disaster management must consider these factors in urban planning. Now let us look into the impacts of high population density. In highly populated areas, disasters can lead to severe casualties and place immense pressure on emergency response services. Evacuations and medical responses can be delayed, compounding the impacts of a disaster. This is particularly evident in megacities where even a small disruptions can escalate quickly due to congestion. An example is earthquakes in Los Angeles can damage bridges and buildings, resulting in widespread disruptions and complex recovery efforts. The denser the infrastructure, the greater the exposure to potential damage. Let us see how infrastructural damage in high density area. High density regions often have densely packed infrastructure, buildings, bridges and roads that can suffer severe damage and disasters. An earthquake, for instance, can lead to building collapses that block emergency routes and trigger secondary hazards like fires. This cascading effect can exponentially worsen disaster outcomes. For example, Hurricane Sandy in October 2012 evacuating New York City highlighted logistic challenges, and that made to realize the need for improved response strategies. Now, let us talk about health hazards in densely populated areas. Beyond physical destruction, densely populated areas are more vulnerable to the spread of diseases. Limited space and poor ventilation can exacerbate health risks during a pandemic or a chemical spill. Addressing these challenges requires strategic planning to ensure better public health outcomes. If you look into the example, the rapid spread of diseases like COVID-19 during 2020-21 in cities like Delhi exemplified how densely populated areas amplify the health hazards. Now, let us talk about the location and hazard prone areas. Exposure of populations and infrastructure is influenced by their geographical location. Coastal, riverine and seismically active zones present significant risk, often requiring specific mitigational plans. This highlights the need for informed decisions about the land use planning and community development. Urban planning measures such as earthquake resistant construction in Tokyo are essential to mitigate exposure risks. Now, let us talk about the exposure in coastal and riverine areas. Communities in coastal and riverine areas face exposure to floods, storm surges and cyclones. Climate change exacerbates these risks by contributing to sea level rise and extreme weather patterns. Proactive measures such as improved drainage and elevated construction are essential in these zones. For example, Dhaka's coastal location makes it vulnerable to flooding, while Nepal's position near tectonic plates exposes it to earthquakes. Understanding these dynamics help us tailor risk management plans and integrating it in developmental plans of the region. Now, let us talk seismically active zones and exposure. Cities like tectonic boundaries or fault lines like San Francisco face constant exposure to earthquakes. These areas require rigorous adherence to building codes and emergency preparedness protocols to minimize damage and loss. The impact of major seismic event can ripple across the entire communities, causing widespread disruptions. Let us look into the mountainous region, how exposure is impacting there. Mountainous regions are prone to landslides and avalanches, particularly during heavy rainfall and earthquakes. For example, communities living in Himalayan region, they are prone to the risk. Steep deforested slopes further amplify this risk, posing a serious threat to local communities. Ensuring stability through afforestation and controlled development is key to mitigating these hazards in landslide prone areas. Now, let us talk about the regions which are prone to extreme weather events. Areas exposed to extreme weather like hurricanes, heat waves face increasing risk as climate change alters weather patterns. Regions like Florida, frequently affected by hurricanes, and Midwest US, prone to tornadoes, are highly exposed to extreme weather. Community resilience can be built through a stronger infrastructure and early warning system. Now, let us look into urban planning for exposure management. A strategic urban planning is essential to manage exposure effectively. Zoning laws can direct developmental away from high risk areas, reducing potential losses. This type of foresight helps balance growth while ensuring community safety. For example, Amsterdam zoning laws prevent residential development in flood prone areas, showcasing how regulations can minimize risk and protect the community. Now, let us look into resilient infrastructure design. In high risk prone, where population density is unavoidable, resilient infrastructure is very vital. Buildings should be designed or retrofitted to stand hazards like earthquakes or floods. Modern engineering practices contribute to structural integrity and community safety. For example, Singapore has implemented advanced flood control system to handle heavy rainfalls, ensuring that buildings and public areas are safeguarded against potential floods. Green spaces as protective measures. Particularly in urban area, green spaces provide a buffer against various hazards including floods and urban heat. They facilitate emergency evacuation and provide a place for community gathering during the crisis. Integrating parks and open spaces in an effective way to reduce exposure, and thus it enhances resilience. For example, Central Park in New York serves as a buffer during heavy rains, providing drainage that helps mitigate flooding while offering safe open areas for residents during any emergency. Community education and preparedness plays a vital role in empowering community to act effectively. Regular training, awareness campaign and early warning system improves readiness and response. Public involvement ensures faster and organized reaction in any emergency. Community education, as practiced in Japan with regular earthquake drills, prepares the resident for immediate action during disasters. Now let us look into infrastructure and critical areas. Protecting essential infrastructure like roads, hospitals, power grids ensures stability during any disaster. Infrastructure resilience supports quick recovery and minimizes long-term impacts. Safeguarding these assets is crucial for community well-being. For example, Hurricane Katrina aftermath demonstrated the severe consequences of damaged infrastructure, where power outages and flooding impacted recovery efforts. Let us look into the various types of critical infrastructure. The infrastructure like transport, energy facilities, healthcare facilities and communication systems are the critical infrastructures. Damage to these can paralyze emergency efforts and this can prolong recovery. Hence, ensuring these infrastructures are built to last is essential for disaster preparedness. Now let us look into what is the impact on infrastructure exposure. Exposure of critical infrastructure can lead to severe economic losses and prolonged service disruptions. For example, blocked supply chains can lead to scarcity of essential goods. Maintaining resilient infrastructure prevents such outcomes and supports efficient disaster response. Hazard exposure leads to direct damage, as seen in 2011 Japan earthquake and tsunami. This event disrupted services, caused economic losses and underscored the importance of resilient infrastructure to withstand disasters. How we can enhance infrastructure resilience? Infrastructure resilience can be designed with risk assessments in mind, tailored to the local conditions. Backup systems and redundant pathways ensure service continuity when primary systems fail. This approach reinforces community resilience and aids faster recovery. Now let us look into adaptive infrastructure solutions. A smart and adaptive infrastructure uses technologies for real-time hazard response. Examples include flood sensors and automated floodgates. Such measures allow communities to respond proactively, reducing the exposure. Now the policy and planning for these infrastructure. Policies like updated building codes, land use regulations are essential for infrastructural safety. Public-private partnerships can strengthen investment in resilient infrastructure. Enforcing these measures ensures long-term sustainability. Sendai framework guide efforts to manage exposure and enhance resilience. Now let us see how community involvement helps in ensuring resilience. Active community participation ensures infrastructural needs at the local level and raises awareness. Collaborative monitoring and support promote a shared sense of responsibility. This involvement enhances collective disaster preparedness. With this, let us look into what we have learned till the end. Today we have covered the significance of exposure, its relation to population density, infrastructure and location. We have highlighted the importance of a strategic planning, resilient designs and community education, and we have also addressed exposure effectively that paved the way for a stronger disaster resilience. And hence we can conclude managing exposure is essential for effective disaster reduction. Strategic planning, resilient infrastructure and community participation and the preparedness are central to minimizing exposure and enhancing recovery capabilities. This ensures communities are better protected. With this, we are going to close this session. Thank you very much. Meet you next. Namaskar.